Now we're talking about set builder notation. Also, another word for that would be solution set. Uses the element of. Element of is highlighted in yellow. It's a symbol that represents, belongs to, or is an element of. So when I look at X and then that symbol N, X stands for all numbers, okay? Any number that we're talking about. The symbol is an element of or belongs to. And then the N we talked about as being natural numbers. The N stands for natural numbers. So X belongs to the natural numbers, or X is an element of the natural numbers. If I don't put that at the end, then you can assume that we're talking about all real numbers. So if I don't put that, then I'm not limiting it to a smaller set. So in the case that we have written down here, here's another symbol that you need to know. The such that symbol. So I have X, all the numbers that we're talking about, such that, and this part says that X is between 8 and 13. We're not including the 8 because it doesn't have a line underneath the inequality, but we are including the 13 because it does have that line underneath there. And X belongs to, or is an element of, the natural numbers. So I'm looking for the numbers between 8 and 13. Okay, so that's 8, 9, 10, 11, 12, and 13 that are natural numbers. Those are counting numbers. But I'm not including 8, so I have to take that one away. And I am including 13, and so this is my set. Okay, so X such that X is between negative 8 or 8 and 13, including 13 but not including 8, and it's a natural number. It's one of those numbers that is counting. It's not a decimal point or fraction. So when we take a look at this, well, these are different types of ways that we can write these problems. The first one is roster notation. Roster notation is actually listing these things out. So I've got the numbers 1, 2, 3, 4, 5. Well, I can list those. And that's roster notation. Interval notation. When I use interval notation, I'm talking about all of the numbers in between two other numbers. Okay, that's all the decimal points and all the fractions and things like that. Well, in this set, I'm not talking about that. I'm talking about 1, 2, 3, 4, 5. Okay, and so interval notation doesn't make sense. I wouldn't use interval notation here. Set builder notation. Again, set builder notation has these certain things. It has X such that, and I'm talking about the numbers between 1 and 5. And I'm including 1 and I'm including 5. And I'm marking it so that X belongs to just the natural numbers. There's no decimal number. So I want also numbers like 1.357, 1.358. And all those numbers, I wouldn't want to list them as a roster. I wouldn't want to list them in a list. There's too many of them. So I'm going to look at interval notation. Okay, so I'm going to put them in an interval. So interval notation starts with a beginning number and an ending number. I started at -2 and I went to 2. And then I have to decide if they're included or not. Well, they both have the less than or equal to symbol. And so that means that they're both included. So I want to use a bracket. If they were not included, I would use a parenthesis. Set builder notation. I'm looking at set builder notation on this problem. I've got X such that. It always starts with that. I already have the inequality, so I have -2 is less than or equal to n is less than or equal to 2. And I could put and X belongs to the real numbers, all the numbers that are in between there, every single thing that happens in between there. But I can eliminate that and not put that, and it will be assumed that I'm talking about all of those numbers. Whole numbers less than 3, the next one, roster notation. Well, that's pretty easy to think of. Whole numbers, so that's numbers that are less than 3. I've got I've got 2, I've got 1, and I've got 0. Okay, and so I can list those in a roster. You could list them as 0, 1, 2, and that would be fine. I probably should have written them that way, and in fact, it's going to bother me enough that I'm going to rewrite them. Okay, 0, 1, and 2, whole numbers. Okay, and whole numbers do not have negatives. Right? Interval notation. Interval notation means that I'm talking about all of the numbers in between here. Okay, I don't want to talk about all those numbers in between. There's no decimal points in whole numbers, so I don't want to do interval notation. Set builder notation. I can do that, x such that I have x is between 0 and 2, and I'm including 0 and I'm including 2. But this time I have to put a disclaimer on it, and x belongs to the whole numbers. Okay, I need it to belong to the whole numbers. It can't be all those decimal points. So here's what we're going to be doing for our homework. It looks pretty much like that last slide that we just looked at, except that I added the graph to it. Okay, and you have one of the portions you need to continue adding until you get everything in here. Okay, so I have the interval notation goes from -2 to 8. Well, I think the easiest one to go to is the graph. Okay, interval notation from -2 to 8. So -2 to 8. I'm not including -2 because I have parentheses there, so that's an open circle. And I'm not including 8 because I have a parenthesis there, that's an open circle. But I'm including everything else that's in between here. Okay, I don't want to list those. Those things there's way too many of them. So roster notation is out. And set builder notation though is okay. So I've got x such that x is between -2 and 8. And I'm not including -2 and I'm not including 8, so those are no lines underneath. And I am talking about all of the numbers in between, so I don't have to put a special set on it, and that's it. I'm good to go. On number 2, I'm talking about the numbers from 3 until infinity. And so I don't want to write those out. There's too many of them. Okay, so roster notation's out. Interval notation, though, will work because I'm starting at 3 and I'm going to infinity. I'm not including 3 because it was an open circle. I'm not including infinity because it's infinity. I can't count that. And so I end up going and stopping like that. Again, set builder notation will almost work in every type of situation because we can put those disclaimers on it. So I've got x such that x is between 3 and infinity. Well, I don't want to write it the way that I wrote the previous problem. I want to say that x is greater than 3. I want all the numbers that are bigger than 3. And again, I'm talking about everything, and so I don't need to put that disclaimer on it. I can just end it. There's set builder notation. In the third one, we've got roster notation. Roster notation, that one looks like they're counting those. Okay, so when I put that together, I've got the numbers -2, -1, 0, and 1. I don't have any of the numbers in between though, and so I've got just these numbers, and so it ends up looking just like those 4 dots. Interval notation, that's talking about all the numbers in between. I don't want to talk about that. I want to talk about just those specific 4 numbers. But I can do that with set builder notation because I've got x is between -2 and 1, including -2 and including 1. But x has to belong to just those natural numbers. Okay? But I can't use natural numbers because I'm talking about negatives. And I can't use whole numbers because I'm talking about negatives as well. Okay, those things don't have negatives in them. So I'm actually talking about just the integer. And when we talk about integers, we use the symbol z or the letter z. Okay, so we're talking about the integers. and then put a squiggly bracket at the end of it. So x is between -2 and 1, and it belongs only to the integers. Okay, I can't say natural numbers because I have some negatives in there. I can't say whole numbers because I have some negatives in there. So I go to the next biggest set, which is the integers. The integers include those negative numbers. Okay. Your job is to continue working on this worksheet and filling it in as you go along. Just jumping down, I guess, to let's take a look at one that has a more than 1 in it. Let's take a look at, let's say, number 15, where let's do the graph. We've got from -5 to -1, and from 0 to infinity. -5 is included. It's a bracket, so that's a closed circle. -1 is not included, so that's an open circle. 0 is not included, open circle. We're talking about all the numbers between -5 and -1, and from 0 to infinity. When we look at listing them, way too many to list. Don't want to do that. But I can talk about them in set builder notation. I'm talking about all of these numbers, so I don't have to put the x belongs to or x is an element of. I can just go x such that x is between -5 and -1. I'm including -5, but I'm not including -1. And x is greater than 0. I'm not including 0, and so I don't put the line underneath it. Okay? I don't have to put the element or the set that it belongs to because it can belong to the real numbers.